Hey folks, welcome back to the channel on the Super Beetle convertible project. We've heard the motor run, which was awesome. We've heard the motor do cool things. It starts, it idles, it does the stuff we would want it to do, lights work, we're in good shape. Very impressed so far with this car. I think I've said that 100 times because I just continue to be amazed. This is probably Beetle number 7 or 8 for me over the years, and this one is by far the most complete. And the most ready to roll kind of out of the gate. So I don't want to break anything by going in here and making a ton of changes, but at the same time, there's some stuff we have to address. First and foremost, it's disgusting in here. There's oil leaks everywhere. There's oil coming out of this, which shouldn't have any oil in it. There's oil all over the tins because of the oil pressure sender leak. It's disgusting. You can't work on it. You can't troubleshoot it. You can't touch it. Like, I'm wearing gloves. I never wear gloves. This thing is disgusting. So we want to take it apart to clean it, but I also thought I would take this opportunity to sort of explain how this system works. Because, I don't know, I kind of started this channel for education purposes. Like, I think that's a fun part of this whole thing is why things work and sort of the process. So that's going to be the plan for this video as part of the series is going to be to explain how all this works, what's been done, what still needs to be done, and then let's get all this apart, clean it up. We'll put some paint on the stuff that's rusting, and we'll fix the oil leaks that we find, and then we'll get it back together. So to start off, I guess we'll do a little bit of an orientation first and foremost. So if we're orienting ourselves on this thing, this here is the air fuel meter. This is an L-jet system versus a D-jet system. The D-jet, and then you're going to have to excuse me because I don't know for sure what the actual German names are, but the D and D-jet, the D is their word for pressure, and the L and L-jet is the German for air. And the difference is the D-jet system uses a MAP sensor, manifold absolute pressure, to kind of control the fuel injection. Great system. Kind of hard to keep tuned because it was so dependent on vacuum that mistakes in the vacuum system really affected the operability far more than the L-jet. The L-jet is air-based, which means it is not based on pressure, it's based on the amount of air that goes past this guy here. It's a hot wire MAF sensor, mass airflow sensor. And that's really what controls and tells the computer what's going on. It knows about every bit of air that runs in the airbox here and ends up in the engine. And we're going to call that unmetered air from the outside and metered air. And the metered air is important because it sort of uses metered air in different ways in the engine besides just sucking it into the cylinders and having it blow up. There's a few components that help this whole thing carefully orchestrate its process. So L-jet systems, the fuel pump pressurizes the fuel up under the car. There's the pump. Maybe it's under the tank. I honestly don't know in a Beetle. Know a lot about the bus. Pressurizes the fuel to anywhere between 36 and 42 psi. It should come in over here. The injectors are, there's 2 injectors over here. There's 2 injectors over here. They are connected with lines to each other. And that it creates a continuous loop of fuel at a consistent pressure. After it leaves over here, it goes to a fuel pressure regulator, which based on a vacuum signal determines what that pressure is. Is it highest max pressure, 42, whatever it is, I forget the specs, or is it low pressure, 38, 36, whatever that is. And that's based on a vacuum signal. Now this thing will run whether that fuel pressure regulator is properly regulating between those ranges or not. As long as it's not way too high or way too low, these things will typically fire off. The other nice thing about the fuel pressure regulator is there is a check valve in it that prevents the pressure from dropping when you shut the motor off, preventing a little bit of a time for the fuel pump to prime the system every time. So that's your fuel loop. Your air loop here comes in, gets metered, enters this plenum here. Now from here, interesting things can happen. It can go down into the throttle body, and then, you know, that's your meter. You control when you step on the gas pedal, you're just opening and closing the throttle body is really all you're doing here. That's just allowing more air in, more air comes through here. It richens the mixture to account for the extra air. There you go. You got acceleration and power. This guy down here adds some variables to how it gets its air. So let's take the air box off, which we should be able to do since I only had it laying on here from when we got the Will It Run video going. So this guy here, I'm going to pop it off. This guy here is, they call it the S tube. Always check this for cracks, by the way, folks. These are original. Usually when they're original, this is under a high heat condition. If this gets cracks in it, you'll be chasing weird vacuum problems and leaks and bad running until you want to throw this in the river. So underneath here, you will see a T. This T goes to two different places. First place the T goes to is this hose here, which runs down to the idle air bypass valve. This is a really important piece to the initial startup of the engine. Initial startup of the engine, this needs more air than it's going to get than it needs when it's warm, because you want to raise the idle up. This thing is very dependent on airflow, but there is a temperature sensor in the head, TS2, that feeds a lot of information to the computer about the temperature of the car. The temperature of the car does have a pretty large effect on the fuel map. So you want a higher idle in the beginning to account for that variation for when it's warm, because the computer is not really all that dynamic in its mapping. It really takes its temperature input, and there's a temperature input in the air meter, there's a temperature input on the head, and it uses those. This guy here throws more air in to raise your idle when she's cold. It's basically just it's a circular orifice. It's pretty small. You put 12 volts on it when you start the car, and in an 8-minute timer closes the little window like a shutter on a camera and closes that air leak off just in time for the computer to have fueled the engine appropriately with enough fuel to have the idle not be too low when the car is warm. So this is a pretty important piece. As you guys can see, it's been disabled. Now, I don't know why it was disabled. My guess, and this is covered in oil like everything else, this looks like these are just broken. And I don't know if this was hooked up and this came off and got sucked into the belt, or if this is a victim of somebody who has a poorly running engine trying to artificially keep the idle up, because that's what it will do. If this disabled, this controlled leak is always there. So it's automatically going to allow more air in than you would want to typically have in the controlled areas, what we'll talk about later. So that's this line, and that will feed air, metered air. Remember, everything after the metering valve is metered. It knows about it. Feeds air into here so that you have extra air for the idle. Or vice versa. It's pulling air out of here, taking the air from here, throwing it directly into the manifold and raising your idle. Basically bypassing the throttle butterfly. Think of it like turning air up around the throttle butterfly without having to actually step on the pedal to do it. You're stepping on the pedal through a valve, which takes its air from here, now that it's been metered, throws it into the engine right through here into the plenum. The other hose on here is for some people, it's called a decel valve, deceleration valve. I've heard them called gulp valves. A lot of people take them off. You shouldn't. I mean, my bus doesn't have one because I can't find one that works, but it actually has the symptom of not having it, which is when you fly off the gas pedal at speed, you're revving on it, you let go of the gas pedal and you snap your throttle butterfly closed. Well, what just happened, the engine was happily throwing maximum fuel in here. You just cut the air supply off. So now you've got a ton of fuel that does not have anywhere near enough air to burn it. Where does it go? It goes into the hot exhaust, unburnt, and then you get popping on deceleration. Pop, 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 pop. It's super annoying. Bus doesn't really do it that badly. I've heard cars that need this valve desperately hooked up. And the way that it works is pretty simple. Here's your feed that feeds metered air into the valve, which is up there. And then based on the vacuum signal it gets, it will open, and this hose here throws that metered air directly into the intake plenum below the throttle plate, and it feeds a gulp of air in to burn that last bit of fuel before you snap the throttle closed. It just helps it. Again, it helps deceleration, popping. If for emissions, it's way better because you dump all that gas in and can't burn it. It comes out the tailpipe. That's all unburnt hydrocarbons. Terrible for the environment. So you really want to make sure that works. It's hooked up on this. All the hoses are in place. It's important. We're going to leave it. The hose that feeds the decel pressure back in here is held on with a zipper tie here and a zipper tie up here, and it's the vintage cloth covered stuff, just like this one. I think we've got some vacuum leaks there. And again, this thing suffers from a high idle. So between the decel valve never closing and all of these vacuum leaks, which are metered air vacuum leaks, but they're vacuum leaks, kind of metered where the hose clamps are not there. You're creating a lean condition and you're creating a high idle. So that's this guy here and the things that he does. We can remove him, her, I don't know. This is also soaked in oil here. This whole engine is soaked in oil, folks. I don't know why. Also, I just took it out. You saw there's this hose here. It corresponds to this monster here. This guy, the bus has one of these as well. That is, I believe, your positive quote-unquote crankcase ventilation. So it's different on each of the cars. This is a very heavy-duty line. There's actually, I mean, I can't even mess with it. It is really hot. It goes in here, though. So if I had orientation correct again, it's like this. It goes in here. That is another source of metered air. Now, it doesn't feed a ton of metered air back in, but all the air that goes past the pistons into the crankcase is actually metered. It knew about it. It feeds that back up. The blow-by goes back in there to be reburned. It's an emissions function. You can plug that off if you didn't want it for some reason, I guess. In theory, I can see plugging that off and then having just a regular polluting breather on here that vents to the atmosphere. And the engine would probably run the same. But why? Why not do it right? So that's what this is. It runs down to here below the oil fill. Something else I've noticed is that there's a pretty nasty oil leak here at this pedestal. And I'm not sure, and that's from me putting oil in it yesterday. I filmed that. I don't know if I'll show you guys the oil change because it's just an oil change. But anyway, that's leaking too. But this hose here, we need to check it for integrity because I see huge cracks in it. That's another air leak potential because it's in the S boot that has vacuum. If these are cracks that go all the way through, you're pulling unmetered air in, leaning the fuel mixture out, you're increasing the idle, all the symptoms that we're having. So that is decel valve, idle air control valve, we'll call it PCV, rebreather, call it whatever you want. So that takes us through the S boot, and I know I've talked a lot already, right? Like there's only going to be a handful of people that want to sit and listen to this because they're interested in how this works. But understanding the system is really critical to making sure that it continues to operate. So other things that are up here before we move on, we have the throttle body, which is a throttle body just like in a regular car. It's just a flap, and it's a controlled air bleed, and there's a big screw right here that allows us to fine-tune the idle. That's allowing air around the butterfly when it's snapped closed to help set your idle. What you'll usually see on these things when you have uncontrolled vacuum leaks is they're screwed all the way in because there's so much air coming in from other places. This is an afterthought. It's just doesn't do anything. Here we have our cold start valve. This is what we had to fix to get this thing running. This cold start valve is required to start the engine when it's cold. There's two things you need to kind of get the engine going when it's cold. You need extra air, and you definitely need extra fuel. The cold start valve, the fifth injector, is what provides that. It determines whether it needs this or not based on this guy right here. It kind of looks like almost looks like a cam or crank position sensor. This is part of the thermotime switch. This is the sensor for the thermotime switch, and all that does, just like the name implies, thermo, heat, time. If this is hot, it won't fire this injector at all. If this is extremely cold, it will fire this injector a handful of times. If it's somewhere in the middle, it'll make a good decision on when it fires that. That is really what the starting procedure process functions need to be for this particular L-jet system. You early start, you're bleeding air, you're putting extra fuel in. As everything warms up, you stop bleeding air, you're not putting extra fuel in. The other piece that's up here, I don't know if you guys can see this, there's a box here. This is actually a TPS, a throttle position sensor. Honestly, didn't think that the late fuel injection still used that. I thought that was like a 70, like 75, 76, or 74, 75 function. Not sure. I mean, my bus has the connection too, but it isn't used. It has the thing there, but it doesn't, there's nothing on the pins. But anyway, that's what this is. It's a throttle position sensor that tells the computer sort of where the throttle is in its sweep. if I had to guess, this is just my guess, it's really just looking for, is it open or is it closed? It's just probably a switch. I doubt it's a rheostat. You know, are you off the throttle? Is fueling? Is the throttle snap close? Undercut the fueling? That kind of thing. So that brings us to the plenum. This plenum here is the source of all of our air and fuel for the cylinders, and air that comes in either over here that's metered, or it comes in metered through these other areas. But basically, that's how everything in here is the air that's going to your cylinders. This guy up here is our EGR valve. And I think I was talking about disabling it in an early video. Someone's done that for us already. I think I've said, I know L-jet really well. I'm not an expert on the Beetle L-jet system because I haven't had one. I wasn't sure how we were going to delete this. Someone's done the hard work for us. Basically, there is and I'm not exactly sure which hose is which, but I'm 99% sure I can guess this right. There's an exhaust hose in the back that's coming off the exhaust manifold, and there is a hose that should be here. And I say hose, these are metal lines. It's here, and it goes down. One of these is going to connect back into the plenum to feed air back in, I think. Basically what happens is, depending on your throttle position and the vacuum signal that it's getting, it'll kick this open and throw exhaust gas back in. That's an emissions. I mean, most cars have these EGR valves, even nowadays. You're going to see them all the time. They basically, it's already burnt gas. So what that means is it's basically inert. At speed, when this opens, it'll actually dump burnt gases into the combustion chambers, effectively lowering the CCs. So it's supposed to be for economy. You know, you have a 1600 cc engine, you start throwing 100 cc's of inert gas at it, now it's a 1500 cc engine because there's only so much room in the cylinders, and you know, you're saving gas. They suck. In this iteration, the Beetle is so underpowered, it does not need an EGR from a economy perspective. You want all the power all the time, if you ask me. The other thing about these is, and maybe someone will argue with me in the comments, they're just prone to failure. You start getting leaks in this system and you've got all these bespoke metal lines. Yeah, actually, you know what? The hose back here, I'm just looking at it now, goes into the throttle body plate here on the bottom. And this would have been the one that gets exhaust from here. So it comes up and goes this way and in. It's still here. Somebody blocked it off with a plate here. It's working. I mean, I don't know. I'm on the fence. Taking it off is going to be a major pain. Like, I have to figure out a way to block off this actual metal line here. And this bracket is part of the throttle return setup. So it's hard to truly delete it physically, but component-wise, this is no longer feeding exhaust gas into anything, no matter what this switch does. So that's the light up on the dash that's lit up that I can't get out, the EGR light that has the timer. That's this system here. So moving down the list, and you know, just to be clear, we're kind of through all the parts of the fuel injection system. There really isn't anything after that that's not standard Beetle. You've got a standard distributor here. Thank God somebody left the vacuum advanced distributor. If you have a 009 on your car of, you know, no vacuum distributor, sort of the race distributors, a lot of the resellers sell them. They've been selling them since I got into Beetles in the 80s. They are not good with road manners. They have a terrible flat spot. I'm sure there's going to be people in the comments telling me I'm wrong, telling me they're great. I don't know how to tune them. I don't care. I've worked on enough of these cars over the years. I promise you, the experience of driving a car with properly working vacuum advance to go along with, there is still a mechanical advance in this distributor. The drivability is so much better with a vacuum advance. I challenge anyone with a 009 to, you know, take me up on that. Swap yours out with a vacuum advance distributor and move on. The truth is, the reason they got popular, in my opinion, the 009 distributors with no vacuum pot, you can buy them for $60. They're cheap. These are expensive. The vacuum pots do go bad. You have to replace them. They're a much more expensive distributor. Fact is, they are a better distributor unless you're running at wide open throttle all day long, or you're running a race car where you don't care about off-idle drivability. Keep your vacuum pot, folks. If you have it, great. If you don't have it, look into getting it. You'll be happy you did. Typical coil configuration, nothing special there. Same air box as all the Type 1s, feeding down into the heat exchangers, which can't wait to show you guys. These heat exchangers look amazing. It's another thing that's not usually in great shape on these cars. They rot out real bad. Now, I have some other little things in here that aren't great that we need to address. This here, I don't know what this is. It goes down out through the EGR hole. Oh, it's not even hooked to anything. What is it? Where is it? Is it a ground? Man, I don't... Oh, yeah. Okay, I have no idea what this is. So, needless to say, I don't know what this is. We have to figure that out. I don't want it here unless it's important. The only thing that I'm trying to ascertain, really, is there's a tack in this car, which is super cool. It's an aftermarket, but it's in there, and it doesn't work. And there's a cylinder head temperature gauge in this car, which is another really great addition so you can monitor cylinder heads, especially when you're flogging it on the highway. I don't know if this is part of that. It's not looking good, whatever it is. This is all bare wire down here, so we are going to need to address that. And I need to find the tack wire. Whatever was in here to run the tack, I've got to find that. I don't know which one it is. But yeah, basic coil, basic wiring. The only things that we really need to do now are start taking this apart so that we can replace all of these janky vacuum lines, clean this up so it's not touching it, isn't an exercise in hand sanitizer and simple green every time. And we'll get it to the point where we can adjust valves and just basically do essentially basic maintenance on it. We'll check the plugs, we'll do the valve timing, the easy stuff. But I don't want to do any of that until I get this cleaned up and establish a couple of things around leaks and whatnot. But yeah, so that's basically it for the explanation of things. I'll start taking this apart. I'm going to keep filming as I take it apart, but I'm probably just going to do a music over or a talk, a fast forward, because taking this stuff off is not going to be wildly exciting, but I may identify cool things while I'm doing it, and I want to film it. So stay tuned for that, and I will get back with you guys talking when we get this apart and start identifying the steps we're going to need to fix this. I think is going to be the first thing we're going to tackle, or maybe the oil leak. I don't know. Let's find out together. So we got progress. I basically just been doing what I've been telling you guys I've been doing. Replacing vacuum lines, reassembling. Really not a lot left now to get it fired back up. This hose here is a pain, man. It's like a U, right? And it's such a short radius that it kinks a hose. They don't really remake this hose. A couple of manufacturers I've seen in Europe make a hose that you can bend. It's like $30. I just need a hose that'll fit that. So I tried some molded hoses, didn't find anything. What I ended up settling on was a 90-degree elbow from Amazon that'll sit right here and just let me bridge these together without the kink. So that'll be here tomorrow. I need to get that installed so I can tie off this vacuum leak. And I still need our friend over here, the oil fill. That thing is really just in the way, not having it. I can't really start the thing until I get the oil fill. That should be here on Saturday. But everything else is in. I mean, I got the surge valve, decel valve, whatever you want to call. That's all cabled up now or tubed up and got a clamp on it. Clamps here. We got clamps here. I still got to wire this up here. I'm going to steal that plug. Coils back installed. It is. I don't know. As you guys can see, I'm not restoring this like show quality. I am making this run well, and I painted the shroud and some of the tins because they're rusting. I don't want things to rust because this motor does get water all over it from the rain. But I also, to do this right, to really get in here and give this the attention that it deserves, you should drop the motor out, take the tins off, blast them, paint them. This tin should be replaced because it's been patched for the new exhaust that someone installed, new to it at the time. So there's a lot of reasons to pull the motor. I'm not pulling the motor. That's not this kind of project. This is get it running, get it on the road, enjoy it a little bit for the summer, and then move it on. So just kind of giving you guys the rundown of where we're at. I will come back when I get these hoses in place and we're ready to fire it up and start tuning it and hopefully get that idle to come down a bit. So, parts have arrived. We got the oil fill. This is what the old one was doing. This is the new one. Just cleaned it up a little bit in the parts washer. doesn't seem to be cracked, should be good as new. And we got some right angle pieces to make this guy here work, this hose. After we get that done, we're going to fire this thing up and make sure we didn't make anything worse, because you just never know when you work on something like this. So let me get these things installed and we will fire this thing up. Okay, so oil filler neck engaged. Yeah, needed that because it was broken, as we showed, and I got the right angle installed here. No room for clamps on this. This is very tight to the body here. This is one of those that you really need good fitting hoses for. You could put a clamp on this one, barb fitting. It doesn't need it. It's not going to leak. I've done this a few times. We got all of our ignition stuff hooked back up, making sure all these plug wires are seated, or we will have a bad time when we go to start it. Vacuum connected. Any vacuum leaks that I create, I don't see any. The dump off valve. Something I did find with this up here, with this this gulp valve, the hose that was up there, I don't know if I'll be able to show you guys or not, if you'll be able to see it, but if you just look down in there, you see how it looks like there's something kind of shoved in the bottom of that hose? That's because there is. Somebody blocked it. A lot of reasons you could do that. I mean, if this valve up here is failing for some reason, you'd want to block it off. I don't know why you'd shove like something in a hose and hide it and make it impossible for the next guy, but we could have a situation there we'll have to deal with if this doesn't run right. Again, this was running before. You guys saw it just ran high idle and a little bit choppy. So we got to see how much stuff was kind of messed with to make it do its thing. There was a lot of vacuum leaks in here, and this wasn't even hooked up. You can see I did reattach this. I shrink wrapped it all. I did steal the wire from the EGR that we're not using, so I have that connected now. I don't see any more vacuum leaks. I don't see anything that would be cause for concern down here. Don't love temp sensor 2 wire in there, but it's on there for now. We'll have to see how that goes. But it should be, in theory, about at least as good as we had it before we tore it all apart, cleaned it, and put it back together again. So let's go hit the key and see what we get. I don't know. There's a good chance it just doesn't start at all. You never know when you start messing with stuff. So let's see. Oh, nope, it runs. Oh, it actually runs okay. As you can see, I don't have the generator belt on. And there's a little bit of a mist going on or something. I don't know if you guys can hear it too. I can see it. It's like popping a bit. Woo. Blowing essentially raw fuel on my pants. So now what's going to happen now that it's running is, you hear how much lower it's idling? This is actually starting to close, this valve here, and it's idling it down like we want, but it's lumpy. Yeah. It wants to stall. I'm going to see if it'll keep running long enough to get warm. I'll come over here. One of the things that we're shooting for here is we want it warm enough that we can adjust some of the mixture adjustments for idle air bypass. There's one on the throttle body, and then there's one actually on that air flapper. I'll explain what they're doing, but you really don't want to adjust those unless it's warm. So I'm going to let it warm up a little bit and see if it smooths out. That looks like a dead mist to me, honestly, because you're getting that like quick hop. But we're going to have to see where it lands when it warms up. It's smoothing out a little bit now that it's warming up. It sounds good though. I mean, I love the way this motor sounds. This thing sounds like a box of rocks compared to this. Hopefully the project under here and those heads there, a little foreshadowing for the Type 4 engine project we're going to be doing. But this is super quiet. So yeah, I mean, I'm going to let it warm up a little bit, and then I'll come back, because you guys don't need to sit here and watch it warming up. I should just only have a charge light on the dash. Yeah, just a charge light, and of course the EGR light, which we can avoid. So yeah, I'm gonna let it warm up a little bit, and then I'll bring you guys back and see what it looks like for adjustments. it's warmed up. It's idling okay. I'm not actually going to make any adjustments. Let me go turn this off. I can only let it get so warm because without the alternator spinning, I'm not spinning the fan. So I'm getting it real hot real fast doing this. I just wanted to see once we got some heat into the head, when the temp sensor comes online and starts feeding the kind of running map to the computer, what we had. A lot of the black smoke cleared up, which is good, but not all of it. I think it's still rich. Couple of adjustments that I think we're going to need to make. The idle air bypass here, I think this is what bypasses metered air. So this is stuff that the computer knows about past the throttle plate to increase idle. So that's one thing we have to adjust. And then up under here, and you really can't see it, there's an Allen screw. There's a bypass in here that lets unmetered air around the flapper. And what that does is essentially lets you, it's like a rough mixture control where you can dump extra air in that the computer doesn't know about to lean things out. I think that's what we're going to need to do to kind of clean up some of the black smoke. I could take the cover off and start to mess with the wipers, but those are really more about like part throttle condition, lean and rich, and then full throttle, lean and rich. I'm just dealing with an idle situation here where I feel like it's blowing a little too much smoke. But before we do any of that, we would be very remiss to start tuning on this without, one, adjusting valves, making sure those are good. They are dead silent right now, and that means one of two things. Either this is a rebuilt engine, I feel like, and it's got all the rebuilt engine tight tolerances, and it's great, or those valves are just tight because they need to be adjusted and they're too tight. Doesn't make sense to start messing around with anything on this motor until we get the valves adjusted, and then we'll throw a timing light on it and we'll check the timing and we'll check the dwell to make sure that the points are adjusted with the right gap. At that point, when we know ignition and compression valve stuff is all perfect, then we can start to play with these settings. But it's a really common problem where people will start turning knobs and screws and trying to mess with stuff to fix what seems like a fast idle, a slow idle, whatever. You don't do that. You don't do that even with the non-fuel injected cars, but you don't do that here especially. So we're going to do those things. We'll the next video I shoot, I was just running it. I'm going to let it cool off so we can do valves. Once we do valves, we'll do ignition timing. We'll check that and make sure that that's right. I also want to pull the plugs because there is like a dead almost miss that is popping up. Could be the fact that it's the points. They could be dirty. They could just have other issues. Or we could have a plug that's fouled. We could have a wire that's got chewed from mice. There's a lot of things. We want to just check the ignition system, and then we'll finish up sort of with a retrospective on tuning one of these things and getting it to perform right. So stay tuned for valve job, ignition, timing, and tuning. I think what I'm going to do is break the video here just so that I can post something up that is, all right, we got it apart, we fixed all the leaks, the idle is low now, we got the idle where we want it, but we still have that running condition we got to solve for. So this video, we got it running again, we're back to where we were without all the vacuum leaks. Now we can do a tune-up and get this thing running smooth so it's like we would want to get it on the road. So if you, as always, if you could like and subscribe, I always appreciate it, and thank you for watching, and I will see you on the next one.